Inverse sine function. So this brings us to our trigonometric functions, and we will start with sine. And our goal is to look at inverse sine function, inverse cosine function, and inverse tangent function. So sadly, the sine function is not one-to-one, but we can restrict its domain to where we still get the full range, but the function does not repeat output values. So there are lots of intervals where this could happen, right? So like I could do that, say, on this interval, pi over 2 to 3 pi over 2, or negative pi over 2 to pi over 2, right? You could kind of think about where on the function we could get the full range of lots of different intervals of x values. But mathematicians kind of, I don't know, all got together one day and decided that they would use negative pi over 2 to pi over 2. And it's kind of nice because it includes the origin. So negative pi over 2 to pi over 2. So that's how we're going to restrict the sine function. So this is the graph of sine. We're going to restrict its domain and pretend that we're kind of throwing out the rest of this just for the purpose of creating its inverse. So since the inverse functions, we know they switch inputs and outputs, right, of the original function. So they also switch the domain and range. So the domain and range of the inverse sine function. So what would that be? Well, let's first think about, let's see, up here for, if we are restricting sine to be one-to-one, okay, then its new domain, right? We say, sorry, old domain is out, new domain is in. You can use this domain only, and then the range is still negative 1 to 1. So what's happening here is because these are inverse functions, they're going to be reversed. So the range is now the domain of the inverse, and the domain of the original sine is the range of the inverse. So let's write those values in. Okay. So the domain is negative 1 to 1, and then the range is negative pi over 2 to pi over 2 for the range. Okay, and again, this is for the inverse sine function. Let's look at the graph. So if we look at the graph, I can see that part of the sine function is drawn in, and really just the part to where we restricted it. And then if we want to draw in sine inverse, well, we know it's going to reflect on that interval across y equals x. So this is all of sine inverse. And we can see that they are both one-to-one and they are each other's inverses. We will see in terms of like how do we write an equation or write for sine inverse. So we'll see y equals sine inverse of x, but it's also called arc sine. So we'll see it like this, y equals arc sine of x. So both of these mean the inverse sine function. So both of these are the inverse sine functions, just we can notate it two different ways. So you'll see both of those just to get used to it. So both of these are the inverse sine function. And I want to just kind of remind us what happens here. So what does sine do? So we kind of have two camps here, where we have angles and then we have some sine value. And so when we take the sine function is going to have an input of an angle and its output is a sine value. Now, what does inverse sine do? Okay, so inverse sine or sine inverse. Inverse sine. What is its job? It's going to take some sine value and it's going to spit out an angle, right? But because of this kind of weird way that we had to make this inverse function, we are going to be only spitting out angles in between negative pi over 2 and pi over 2. Okay, and so that's how everyone can still be a function and all that kind of stuff. So we can only have one output, and so those outputs need to be in between negative pi over 2 and pi over 2. So that's this little diagram I think is going to help us when we think about the sine and inverse sine, because it's easy to kind of get it mixed up. Sine is, okay, we put in an angle, we get out some value. And now what is inverse sine going to do? It's going to take that sine value and say, where did this come from, right? It kind of goes backwards. So if I get a sine value, it says, here's the angle where it's from. But we say, wait a minute, that could have been from a bunch of different angles. And it says, sorry, I have to restrict to between negative pi over 2 and pi over 2. So now we're going to evaluate each expression, which are just using inverse sine functions, and we just want to kind of get used to it. So sometimes it helps to write out the question. So sine inverse of 1/2, what is this really asking? So this is really asking, what angle between negative pi over 2 and pi over 2 produces a sine value of 1/2, okay? And we usually need a unit circle drawing at some point for these, so I'll just draw a little unit circle. And where is, so first I go, well, where's negative pi over 2 to pi over 2? Because I don't want to look where I'm not allowed to, right? Because it's saying what angle between negative pi over 2 and pi over 2. Okay, and then in that little range, right, where I'm allowed to be, does sine hit a value of 1/2? And we know that it does hit it at pi over 6, right? Because this point right here is root 3 over 2 1/2. And 1/2 is the y-coordinate, so it corresponds to the sine value on the unit circle. So what I found is, the question was, what angle between negative pi over 2 and pi over 2 produces a sine value of 1/2? And we say, that angle is pi over 6. So since the output of the inverse is an angle, we see sine inverse of 1/2 is equal to pi over 6. All right, what about arc sine of 1? So it's the same idea. It's what angle between negative pi over 2 and pi over 2 produces a sine value of, instead of 1/2 like the first problem, what produces a sine value of 1. Okay, so I'm going to do the same idea. You can always write out that question if you want to, because that certainly helps. And I'm going to highlight just where I'm even allowed to be looking, which is, right, we have to go up from there or down from there. So between negative pi over 2 and pi over 2, and where does sine equal 1? Okay, so only one place, and that's why this is possible. If there were multiple places inside this range, then it wouldn't be a function, right? Because it wouldn't have the same output every time, or it'd have more than one output. Neither of those cases we want. So it hits 1, sine value of 1 time in that range, which is what I want, and it is at the angle pi over 2. So this whole thing is pi over 2. All right, sometimes if you do a bunch of work like underneath where the original question is asked, it's kind of nice to just rewrite that expression and just write arc sine of 1 is pi over 2, just to kind of show like, here's the work that I did, and then here's my conclusion. So it's kind of in that logical vertical order. All right, last one. What about sine inverse of negative root 2 over 2? Okay, so again, this is asking what angle between negative pi over 2 and pi over 2 produces a sine value of negative root 2 over 2. So I just do the same thing like every time, and I go, it's going to be between negative pi over 2 and pi over 2. So where does that happen? Well, I'm really looking for a y-coordinate on the unit circle of negative root 2 over 2. And I know that only happens one place, which is good. It's down here in quadrant 4, and because this point here is root 2 over 2 comma negative root 2 over 2. All right, well, what angle is that? Well, be careful, because think of this as like, I don't know, weird fires. Not sure what I'm drawing here, but it's not allowed. So you're not allowed to go over there. So in order to get to this angle, right, the spot that I want to be at, I need to get there by starting at that positive x-axis, but then going in the negative direction. And so this gives me negative pi over 4, right, because I'm going that clockwise. So what I found is sine inverse of negative root 2 over 2 has an output of negative